Namaskar, I am Dr. Rama Paudel. Welcome to 8th episode of SCIPOD, the conversation on science, policy and development issues in Nepal. Microbes are a group of organisms that are too small to be seen with the naked eye. But have shaped the course of humanity. Worldwide, this tiniest part of ecosystem play massive role in driving the economy by energizing agriculture, transportation and pharmaceuticals development.
Global IME Bank, सबैका लागि bank.
Our understanding of microbes and microbiomes will likely transform our way of life, providing novel therapeutics, alternate energy sources, and shaping fundamental doctrines of biology. But the story of how microbiology drives vital processes that support the bioeconomy has not been well understood. In this episode, we will be discussing the status and prospect of microbiology in Nepal. Our guest for today is Dr. Devraj Joshi. Dr. Joshi is an associate professor of microbiology at Tribhuvan University with over 20 years of experience in research and education in functional microbial ecology of natural and engineered aquatic ecosystem, including bacterial diversity, antibiotic resistance, and potential pathogens in water and wastewater. Welcome, Dr. Joshi.
Thank you so much, Dr. Rama. Thank you for having me in your show. Thank you.
Why do we need to care about the microbes?
Microorganisms are so important for this whole planet. We can assume any life forms in this planet that were initiated from the microorganism during the evolution, and even today microorganisms are there. They will remain forever, hopefully, but any other life forms will not survive in absence of microorganisms. They are so intimately associated with other living beings like our body as well as other abiotic system. So all the phenomena or the activities that take place on this planet, this is governed by microorganisms. So they are ruler on this planet. So they are so much important. Now, why they are so much important for us, for a human being, is my answer is this. We have two aspects. Number one, why microorganisms are important as an individual for me, because in my body, microbial cells are more than my own, and they are governing my health. What generally we say got microbiome, microorganisms which are in our digestive system. And so now we can predict your mental health, your physiology, and for example, your obesity. It depends upon the microorganisms with what they are in our gut. And this has given us the opportunity that we can treat your diseases. We can manipulate the gut microorganisms and we can treat you. Besides, microorganisms are infectious. They cause the disease. There are so many deadly diseases which are caused by different microorganisms. What we say, of course, bacteria, viruses, these are very common one. Besides, there are a lot of protozoans which are also microorganisms, and there are fungus. Basically, the single cell fungi, what we say yeasts, they also cause the diseases. But very interesting part is that this harmful microbial population is negligible compared to the beneficial microorganisms. So, because they are involved in all the phenomena in this planet. For example, they are involved in the purifying water in rivers or in ocean. They are involved in decreasing the volume of the solid waste. They treat the solid waste, and a lot other, for example, the
composting,
enzymes, of course,
nitrogen fixation in agriculture, right?
Agriculture, yes. Different microorganisms act as a biofertilizer. Many microorganisms act as a biopesticides. So these microorganisms can be utilized and can be improved for the further development of human life, or to make the easier the human life. So it is so vast, right?
The microorganisms are there from the beginning of human civilization, but I just wanted to know when was the study of microbes started globally, and when it was started in Nepal, and how it's growing in Nepal.
In global perspective, microorganisms were there on this planet, in our body, from the very beginning. In fact, we believe the first organism evolved on this planet was the microorganism. And slowly, when the civilizations developed and people started to think about themselves and making the things more developed, probably they might have known about the microorganisms, because they knew that the cholera or any diarrhea transmits if you are contaminated with the fecal matter. They used to know if you drink the dirty water, you will get sick. Or they used to know that how to make the wine. And they also used to know that how to increase the agricultural productivity, right? They might have been using some fungus, what we say, mycorrhiza, or some other bacteria. But at that time, they had no name. And the studies were not very much formal. Later on, when the science developed, particularly in the 17th and 18th century, science became more formalized, and we started education in the universities, and microbiology emerged as one of the field where people started to understand the microorganisms. So first time microorganism, what we know according to the document is it was Anthony van Leeuwen who for the first time, because he was the lens grinder, and he used to make the lens. By his own lenses, he saw some tiny creatures in the water, what he said, tiny animalcules. Later on, that the different scientists who worked on that, Louis Pasteur, Robert Koch, right? So with these different studies, we came to know about this microorganism. Later on, we gave the name to the bacteria. We developed the taxonomy. We divided them, the microorganisms, in the different classes and phylums, and now we have the names, and we know their role now, what they can do in the environment or to the human body, or what type of the organism can be used for the industrial perspectives. Now we know. But still, many microbiologists globally, what they suspect that we know very little about the microorganisms. Probably we know less than 10% of the microorganisms, what we believe they should be over this planet, particularly on the Earth. So this is because still the methodology to explore the microorganism. The basic problem with the microbiologist is microorganisms are not viewed by naked eyes. You need some aid, or you need to proliferate microorganisms in your artificial laboratory culture plates. But many microorganisms are not cultivable. So, so we don't know many microorganisms. We know some uncultivable microorganisms now using some genomic, what we say, omic approach, but still we do not know many. So whatever the microorganisms we know, they have also comprehensively impacted on our life, not only the individual life, but also our prosperity and the economy as well.
Yeah, in globally, as you said, it was started in 1700, 1800,
Yes.
and how did the formal education in microbiology started in Nepal? How that affected how that helped to manage some of the problems in agriculture, wastewater management, or industrialization? How that work in our system?
Right. In Nepal, before 1990, we had only one university, that's Tribhuvan University. And before the concept of the microbiology emerged, microorganisms used to be taught in botany. Because even if you see the very old textbooks of botany, they have included microorganism as a in the taxonomy of the plants. So in the beginning, until 1979, some parts of the microbiology were used to be taught under the botany. But in 1979, for the first time, Trichandra College, which was the central campus of Tribhuvan University at that time, BSc in microbiology started. It was a 2-year course. And nearly 11 years later, Tribhuvan University started its central department, where they started master's program at the beginning and then later the PhD program. So and it is both the BSc microbiology in the different constituent colleges of Tribhuvan University and many affiliated colleges, BSc microbiology is running perfectly. And master's microbiology program is also being operated by the central department as well as other many affiliated and constituent colleges in Nepal. And it is continue up to the date. Students and Central Department of Microbiology also offers the PhD in microbiology, and now we have the tremendous flow of the PhD students in our department. We have developed in these 30 years or 35 years, we have developed microbiology a lot, but it is not enough. In the beginning, even in my time when I did masters in 1999 to 2000.
Did you do your masters or PhD here in Nepal or abroad?
No, I did masters here in Nepal, but PhD in abroad.
Which country?
It was Chinese Academy of Sciences. We say Research Center for Eco-Environmental Sciences. Because from the very beginning, my interest was in environment. We had a trend in microbiology that.
How do you describe your work, or the value of your work in Nepalese development, and why should we need to teach students microbiology here in Nepal?
Right. It's a very interesting question. Thank you so much for asking this question. Tribhuvan University, I don't want to be much negative. Tribhuvan University does not pay us for research. Tribhuvan, we are hired for teaching, not for research. And in our job description, there is nothing about the research. We mentor, we guide some thesis students, but that is not, the main part of our work. We teach. But microbiology is the laboratory-based science, right? And just by textbooks and just by lectures, you cannot understand microorganisms. What would you say to your students? There are some invisible things, and they do this. Until you demonstrate it, your students are not going to adopt it. So, laboratory work, laboratory demonstrations are very much important. And when you are doing these laboratory things, then you can design the experiments. And this accumulation of experiments slowly goes towards the research, because you can generate the data from the experiments. So what we are doing at Central Department is every master's student mandatorily should do the thesis, dissertation work. And since I think last 3 or 4 years or 5 years, I don't remember exactly, even our BSc students need to do project work, which is also a kind of very small mini research. And the student come up with the different ideas. And there is a process in the research. First, they have to identify the problem. what the problem they see, and they should convince their faculty, supervisors, and as a whole to the department that this problem is important. Then they design the research, conduct some experiments, and then the output is discussed. And research is sometimes searching a black cat in a dark room. So you cannot guarantee that you will succeed, though you know the problem. For example, I know one guy who guided me during my PhD. My PhD professor, they worked on environmental antibiotic resistance, I think since 1992. Last year in 2023, we were in Hong Kong in a conference. He said, Dave, I discovered one thing. So I said, what? Now I realized the wastewater is so complex entity that we need to work more on this. After nearly after 30 years to work on that. So you cannot. You can set up some timeline for the research. That's true, particularly for some innovations, some work. But all the times, if you are lucky enough, you will get something. Otherwise, you may not. But still, now science, is becoming neither black nor white. Now we are explaining science as a gray matter. If you wish, you can make it white, or you can make it black, because it is all about the interpretation, how you are looking on things, what is your angle. So my angle to see the microbiology research in Nepal is, it is progressing, but not to the point that where we can claim that we are aligning with the mainstream microbiology research in the world. We have progressed because 20 years ago, I remember we used to cultivate microorganisms. Now every of our master students do PCR. They talk about sequencing. They talk about the omics technologies to explain the microorganisms.
We have enough laboratory facility for omic techniques and
we are developing it. We are developing it. We do not have enough. You can visit my department at Tribhuvan University sometime. It is a very small building. We do not have enough space, and these omic technologies are very much expensive. We are paid by the taxpayers' money, by the government. Though the good thing with my department is we have a lot of projects running, and we have gathered a lot of instruments. Now we do sequencing as well, but yet it is not much developed. So this is something like I can tell you one story that in my village there was a family. They used to say, when you migrated from hills to plains, Tarai, did your economy increased? So he had a very beautiful answer. What he used to say is, in hills, we had 4 plates for the dinner, and we were 6 people in the family. Now here, our plate numbers increased to 9, but now we are the family members 12. Even in the hill, their number of the plates increased from 4 plate to 9 plate, right? But still, they had to somebody had to wait for the dinner at the plates were limited. So it is the same thing with us. We have developed a lot, but it is not enough.
No, but one thing that I wanted to focus in this program is how our research is advancing, and it's great to know that this latest technology, omic technology, is latest in the world as well, right? Genomics, omics, all this technology are latest, and we are also practicing it here in Nepal. It's great to hear about that. Let's come back to the microorganisms again. So I just wanted to know what are the major microorganisms, although there are lots of microorganisms are around everywhere, but the main microorganisms that we need to focus on, the beneficial, the harmful microorganisms, can we just talk about that?
Yeah, that's really interesting. It depends upon your focus on the different fields. For example, for the medical microbiology, if you want to help with the treatment and cure of the diseases, then we have to use certain microorganisms that can give us the antibiotics. Antibiotics are the chemical compounds which are obtained from the microorganisms. So these organisms are called actinomycetes. These actinomycetes can produce a lot of antibiotics. Nearly 75% of the antibiotics what we do have now, it comes from actinomycetes, right? And these actinomycetes produce antibiotic as a secondary metabolite when they are growing in the harsh condition, for example, in the high altitudes. So probably in our Himalayas there would be lot of actinomycetes which would
That
produce
can be used as
they can be used to produce the antibiotics. And this is much important because we are undergoing a tremendous pressure of antibiotic resistance.
Sure.
Right, and even the WHO or many other institutions predict that after 2050.
Are we conducting any research on antibiotics
Yes.
resistance in Nepal?
Yes, of course. We are doing. Myself is also involved in antibiotic
Are there any
resistance.
pathogen or the microorganisms that are identified that are resistant to certain kind of? Can you provide some examples?
There are a lot of government itself does antibiotic surveillance. National Public Health Laboratory at the Tegu, they have 5 or I think more sentinel centers in all over the Nepal, and they monitor the antibiotic resistance to the pathogens. And in the recent days, what this government data and other individual research data suggest that antibiotic resistance is ever increasing. For example, Salmonella typhi, which causes the typhoid, right? E. coli, that causes diarrhea, and E. coli has a lot of other aspects also, because it is also the indicator of the fecal pollution, right? And even tuberculosis, for example. Tuberculosis is caused by Mycobacterium tuberculosis. In the beginning, we used to say antibiotic resistant Mycobacterium tuberculosis. Later we said multi-drug resistant tuberculosis, right? Now it is XDR tuberculosis, extremely drug resistant tuberculosis.
Okay, when like certain pathogens, the multiple pathogens are resistant to certain antibiotics, then it is difficult to cure those diseases,
Definitely,
right?
definitely.
And then
It
that
is
could
very,
be
very difficult.
very problematic in countries like ours. And there are some reports that even we eliminate, such as malaria, once we eradicate or eliminate the disease, they're coming back again, right? In many
This
countries.
is what we call reemergence of the pathogens, and many of pandemic and epidemic diseases that are being spreaded. This one of the reason is the reemergence, and one of the major factor for reemergence of this pathogen is the drug resistance.
Yeah, other fields beyond that. Okay.
Besides that, industries. For example, the enzymes. Let me give you a very basic example. We have a lot of wine industries, right?
Wine, dairy.
Dairy, right? And in the wine industries, they need microorganisms at. There are a lot of stages, 2 more particularly important stages. One is for the production of the wine, what we need some yeasts, right? What we call Saccharomyces. And we had some indigenous sources of these yeasts. In Kathmandu, they say mana, manapu. This is the rice cake, which contain these yeasts. But many wine industries, they buy yeast from outside the Nepal. And the second, after production, you need to clarify the wine, right? For that, because that a lot of woods and fruits are used
In
on that.
every process of wine development, we need to have utilization of microorganisms.
Microorganisms, right? For this, we need pectinase enzyme. Pectinase enzyme can be produced by any bacillus, right, subtilis, or any bacillus that can be found in everywhere in the soil, right? But our wine industries are buying this pectinase enzyme from abroad, from India and other, and that we are losing $1 million. And
If we could develop that technology in Nepal, we
yes,
could save that
yeah,
money.
that's why we need bio-entrepreneurship in the microbiology.
Yeah.
Right.
Other sector like waste management,
Agriculture, right? In agriculture, as you said, the biopesticides and biofertilizers, phosphate solubilizing microorganisms, nitrogen fixing microorganisms, and the biopesticides like there are a lot of bacillus species like Bacillus thuringiensis, is used. So that is one part that we can focus. And now if you come to the environment, we use microorganisms much enormously. For example, for the treatment of the solid waste.
You are also working, your specialization
Yeah.
is in wastewater management. Let's hear about your research and environmental microbiological perspective.
Yeah, thank you so much. This is the area where I like to talk much about. My research is on the wastewater microbiology, and wastewater microbiology itself is very big, because the wastewater treatment, what we say biotechnology, it is a biotechnology because we use the microorganism for the treatment, and this is the world's largest biotechnology application. We do not work in all, but I work in the three major aspects. One is the biological treatment of the wastewater. This is much more important. In Kathmandu, nearly 10% wastewater generated by the Kathmandu is treated. That is also partially. Rest 90% of the wastewater generated by Kathmandu is directly discharged in our rivers, basically the Bagmati River, and you can see the status of the Bagmati River, right? No aquatic ecosystem is operating there. So we need wastewater treatment, and in the coming days we have to increase the wastewater treatment capacity, because as you intake the drinking water, 80% of the drinking water converts to the wastewater. So if you are bringing the Melamchi or other Cisneri to your drinking water system, you will be generating more wastewater. So you have to develop the more wastewater treatment capacity, and the microorganisms are the best for the treatment. They are environmentally friendly, low cost, and you will have an opportunity to sustain the system, because microorganisms themselves can produce energy which can sustain the system. That is one aspect, and the second aspect is the where I work is the wastewater based epidemiology, where without touching the individuals in the community, we explain their health status. Right? We for the first time worked on this area during the COVID pandemic. In that time, we used to collect the wastewater from 21 different sites in Kathmandu, and used to monitor where the coronavirus is being increased or where there is a possibility.
Seems
to
like
decrease.
the microbiologist can help to early warning certain
Exactly,
diseases, and that's
exactly.
very important for the human
Exactly.
health and the public health issues. Right?
That's
Yeah.
true. And now, cholera in the, Kathmandu is the epidemic for the cholera. Now, we are one of my students is trying to understand the feasibility that whether the cholera can be monitored as an early warning system in the society. And the third part that I work on is the antibiotic resistance in the environment, in the wastewater, because wastewater is the best vehicle for the transmission as well as the proliferation of the antibiotic resistance. We spread the microorganism to the wastewater, they develop antibiotic resistance there and come back to our community. So we are trying to understand the mechanism that why wastewater systems proliferate antibiotic resistance, and is there any possibility that we can stop, we can check the proliferation of antibiotic resistance. These are three main directions that I work. And this is
it seems like a very promising area of research. And do you see any policy implications? How that does your work translate into the policy documents in Nepal?
yeah, it's a bit tricky question. There are policies in Nepal. For example, there is a biotechnology policy that came in 2006. There is a whole document of biotechnology policy. It explains about the biotechnological applications. Biotechnology is basically the majority is the microorganisms that, but this whole document nowhere it mentions a single word about microorganisms.
Why is that?
I don't know. It talks about animal biotechnology, plant biotechnology, right?
Why I'm asking this, I have seen lots of scientists working in different issues, and there is I would not say enough progress, but we are progressing, as you mentioned. But coming to the implementation of our work and to the public level, we need to have the translation of our work into the policy document, right?
Exactly.
So, like, I'm just interested on knowing how the work of microbiologists is translating into the policy document. Where is the gap, and what would we do to make it work in future?
That's interesting, and it's a bit tricky, as I told you. It depends upon the individuals, policymakers, and authorities that how they adopt the things. For example, we are publishing the papers. This is what a scientist can do, right? Rather than we can advocate, but we cannot force anybody to implementing it. For example, this wastewater-based epidemiology, we discussed with the health sector. We discussed with the policymakers. And we tried to convince them that let the government start its own environmental surveillance of the key pathogens that are being circulated. It has been nearly 3 or 4 years. Still, there is a very faint response. Now, Kathmandu Valley Board for Water Supply Management, they have initiated wastewater-based epidemiology. It's a very primitive stage, and Tribhuvan University, my group, we are particularly helping them, giving the technical assistance. I hope that will go further, and regarding the antibiotic resistance, we are monitoring 9 hospitals in Kathmandu. Presence of antibiotic residue as well as antibiotic resistant bacteria and their genes. We have found that hospital wastewaters are the key source of antibiotic resistance, and they are the reservoir, and from that it goes to the municipal wastewater and then to the river waters. So that is the path for the circulation. So in between there are the critical points where they can be checked. So we are advocating now that every hospital mandatorily should have the treatment plant where they can remove the microorganisms.
Do we have the policy document that make it mandatory for the hospitals to do that?
Yes, in document, in principle, it is, right? But I don't know the monitoring system, and but what our research shows that these wastewaters are not pretty well treated.
So it seems like the policymakers and the scientists need to work together in reviewing some of the policies so that we can have it translated in a better way of your work. As you were the mentor, the teacher, faculty in microbiology, you might have mentored many students in your career. What is the gender status of your students? And often, like, I talk with the female guest, how could we improve the participation of female scientists? But I would like to ask you today, what is how could we improve the work? Like, how could we motivate females to be scientists in Nepal?
Right. In Nepal, I don't know what is the global trend, but in Nepal, more girl students are attracted towards the biological science. Nowadays, you can see a lot of women or the girl students in engineering or the physical sciences colleges or their departments, but still the majority come to the biological sciences. I do not know exact the motivation behind that, but maybe our traditional belief that if you have a doctor, she will be if you have a daughter, she will be a doctor, and if you have a son, he will be an engineer. Probably that mindset works. Right, and if they cannot get admissions or they are not really interested to the medicine, probably they go to the other biological fields, and a large number of students come. But the sad part is, after the completion of the degrees, either they join academic institutions as a teacher of the microbiology, or they just disappear. I know, from my batch, in nearly 25 years ago, I remember some of my colleagues who were women, they are housewives now. Can you just imagine?
So what we need to be successful female as a scientist?
Yeah. So the major thing that is the social concept that the women should be confined within the home environment. That may work, I don't know, or they do not want to take much risk in their career, right? That may be another reason. And in the higher level, there is some kind of belief, for example, particularly for the young girls. When I was doing my master's, I recommended my mentor that can you take one of my colleague? She is very good student. He refused. It was in Nepal, but it was 25 years ago. He refused. What did he say to me? You cannot predict about the girls. Tomorrow they will be married, and where they go, nobody can track out them.
Still, like
and after marriage, probably their husband or their families may decide on her future. So
unfortunately, that is the scenario, and
right.
We need to have supportive
So
family
what we can
spouses.
do, that is much more important. Number one is the awareness on gender equity is very much important, and the young students who are girls, they should build up their confidence. That is very much important. For example, to my students, I say in the first day when they come to my lab, at the first day I say, please start saying no. First say no to me, then you can say no to the others. That will change your life. Saying no means you are responsible to yourself. You are able to decide yourself. So that confidence is very much important. And third is probably the financial freedom is very much important, I guess, because at that time they are not able to earn by themselves. The same situation is for the boys also.
We were teaching most of the female students, and we are grateful for faculties like you who are mentoring, creating the enabling space for the female scientists. Now, the problem are getting there are novel problems in every field these days,
Right.
And then we need to have an innovative approach to solve this problem. What would be your message to the new generation coming in the field of microbiology in Nepal?
For the new generation is this subject or any subjects, they demand the hard work. That is the primary thing. If you do not have the skill, you cannot exist. That's the primary thing. During my project, I was requiring for one individual who could do the real-time PCR. We did advertisement. There are a lot of microbiologists who do not have the job, but no one came to me. And I requested someone who had idea on that, right? So skill is very much important. So develop the skill from the very beginning, from your undergraduation, right? There are some techniques, because this is the laboratory-based science, right? Just by talking, you cannot be a microbiologist. You have to work on the laboratory. You have to understand the microorganisms. So hard work is the very first thing. Second thing is be focused on what really you are interested on. If you are not interested, in AC rooms where the temperature would be sometimes less than 10 and you have to work for 24 hours, whether you have a passion for that or not, right? If you enjoy much with the public relation, talking with them, going in the field, right? That is another interest. So be focused with your own interest. If you are interested on that, you have a skill, you have a confidence, and you are focused. That is particularly important to be focused on that. But one thing very confidently what I can say is there is a big and a bright future of microbiology in Nepal because everything associated with the human being is related with the microorganism.
The objective of this show is science advocacy, and do you have any message to policymakers, donor agency, researcher at last to deliver from this show?
Yeah, I mean, believe on scientists. Listen what they are saying.
Exactly.
Right? That can solve a lot of problems, right? There should be a triangle type relationship between the government, industries, and academia. Industries, they have a problem because they produce something, and during their production they have a problem. University have the human resource and they can find the solution for that problem. Exactly. And this relationship between the industry and academia can be regulated by the government, right? So this relationship, the triangle relationship, should be developed, listen to us. And sometimes there is a problem that particularly it happens in the developing countries that within the science sometimes people do not respect others' discipline, right? Some people say, we are scientists, we are doing great job. They are not, right? Say for example, I blame for the geologists. What's their work? So we have to develop the multidisciplinary research, right? Exactly. I need clinicians for my research, I need geologists, I need botanists, I need chemists, and we have to develop this multidisciplinary approach. Please take out your subjects from your dark rooms of universities. That is very much important.
Exactly. It was a great pleasure to have you. So it was a very insightful talk. Thank you so much for joining with us. And I hope we will be able to work together and advocate in some of the issues that we are discussing today in future as well. Thank you so much.
Thank you so much.